So the last topic of this organic chemistry is condensation polymerization. What is condensation polymerization, or what happened in condensation polymerization? Small molecules join to form a long chain compound with elimination of water molecule. Means small molecule join to form a long chain compound, that is a polymer, and there's also a water molecule is released, and this type of polymerization is known as condensation polymerization. And condensation polymerization occur between amine and carboxylic acid, carboxylic acid and alcohol, and alcohol with another alcohol. So these are the only three possibilities. If a molecule, one molecule is amine, another one is carboxylic, then they can form a condensation polymer. If one molecule is carboxylic acid, another one is alcohol, then there will be a condensation polymer. Or if both of the molecules which are reacting are alcohols, then a condensation polymer can also form. So these are the three possibilities in which condensation polymer can form. Amine means here NH2. So if one of the group is NH2, one molecule contain NH2, another molecule contain carboxylic, they can form a condensation polymer. How it can form, that I will explain. But first thing, you can identify from the structure that whether they can form a condensation polymer or no. So if one of the molecule contain amine, another one contain carboxylic acid, they can form condensation polymer. Or if one of the molecule is having carboxylic acid, another one is alcohol, they can also form condensation polymer. Or if both molecules are alcohols like OH, they can also form condensation polymers. First copy this part, then I'll give an example to explain how a condensation polymer is formed.
So, sir, this doesn't occur between hydrocarbons?
No, it is not for hydrocarbon. Organic compounds will be there, not hydrocarbons. So how this polymerization done? So I'll give example how this polymerization occur or how polymer is formed. So example, and to form a polymer, you should have a many molecules of monomer. So example, we have many molecules of, the first one is formation of nylon. Nylon itself, the nylon ropes, it is used. So this is also a polymer. How it is formed? So nylon actually contain many molecules of the monomers are many molecules of diamine and dicarboxylic acid. So many molecules of diamine and dicarboxylic acids are the monomer. What does it mean? The term diamine, di means two, and amine means NH2 group is there. So when we draw the structure of a diamine molecule, so amine means NH2, so N, H, H, and between, like di, the term di means two, so there is also N, H, H, and between them there are carbon atoms. Many carbon atoms are there. So instead of drawing these carbon atoms, what we can do, because it does not make difference how many carbon atoms are there, it does not make difference to how a reaction occur or how a product is formed. So instead of drawing the carbon atoms, we can use a symbolic representation. Maybe 10 carbons are there, maybe 6 carbon atoms are there, 4 carbon atoms are there. So it will not make difference. So I can just use a symbol here. I can just use a box, a rectangle, to show that there is a carbon chain. Is it clear? This is called diamine. Why it is called diamine? Because two amine groups are there. This is one amine group and this is a second amine group. So two amine groups are there and between them there's a carbon chain. So instead of drawing the carbon chain, we just use a symbolic representation. We just draw or make a box. Then the second monomer, dicarboxylic acid. So dicarboxylic acid means OH, C double bonded with O, and OH group will be there. So the term di means two carboxylic groups at the end. And between them, there are carbon atoms. But instead of drawing those carbon atoms, what we can do, we can also use a symbolic representation, because the polymer is formed by the reaction between the ends of the molecule, not at the center. So it will not make difference how many carbon atoms are there. So just to represent that there are carbon atoms, so we can use a symbolic representation here. And if they have different number of carbon atoms, so we just shade the region. When we shade the region, it means different number of carbon atoms which were present in the first molecule. And there are many molecules. In the monomer, you have many molecules of diamine. So there will be another amine molecule. These are the monomers I am drawing. Monomer means the molecule, small molecules are called monomer. When they will join, this will result in a formation of a polymer. Is it clear till now? The structure of the monomers. This one is diamine. So one molecule is diamine. Di means two. And amines mean NH. And the other one is dicarboxylic acid. These are the monomers. But how they will form a polymer? So formation of the polymer, how polymerization occur? So what happened? Amine will lose its H hydrogen. So amine will lose its H. Carboxylic will lose its OH. So when H and OH being lost, what it will form? It will form water. Same thing, carboxylic acid will lose its OH and amine will lose its H. Amine will lose its H, carboxylic will lose its OH. And same thing happen, this will continue because we just draw two molecules of amine and two molecules of carboxylic. But there will be many amines and many carboxylic acids. So amine will lose their hydrogen and carboxylic acid will lose their OH. So what will be the result of this? So we just remove H and OH. So if I remove this H, so there will be nitrogen, this hydrogen, then this box represent there is a carbon chain, then nitrogen and hydrogen. And you can see this H and OH being removed. So if I remove this H and OH, so this will be C double bonded with O. So H and OH being removed, so C double bonded with O. Then this box is there. Then C double bonded with O. Here OH and H being removed, hydroxide and hydrogen are removed. So what you are left with? Carbon and nitrogen bond. The box is representing a carbon chain. Like example, if there are like example 10 carbon, 20 carbon, 5 carbon. So between them, there's a carbon chain. So instead of drawing the chain, we can just use a symbolic representation and we can just use a box here. So this box is representing a carbon chain, and using a different symbol for a box shows that different number of carbon present here might be different from number of the carbon present here.
Sir,
So
can you repeat it one more time?
OH and H being removed. So if I remove OH and H, so it will be N, H, then this box is there, then NH, then H and OH being removed, so nitrogen will form a bond with carbon, so C double bonded with O.
Sir, can we put a line instead of a box?
If you put a line, it means, if you put this line like this, it means there's a direct bond between carbon and the carbon. So there is no direct bond between them. That's why we represent that there's a carbon chain, and instead of drawing the whole carbon chain, we just use a symbolic representation as a box. If you draw a line and make a line between them, it means one carbon is directly attached to another carbon, but it's not direct attachment. Then C double bonded with O. So you can see this is a very long chain compound, and this long chain compound is known as nylon. So diamine, look, what are the monomers here? The monomer is diamine. This is called diamine. Why it's called diamine? Di because two and amine groups are there at the end. That's why it's diamine. This is dicarboxylic. This is also diamine. And this is dicarbo. So when they react with each other, so what happened? Amine will lose their H and carboxylic lose their OH. So when amine loses its H, carboxylic loses its OH. So H and OH being removed. So you can see amine hydrogens are removed and carboxylic OH is removed. So you're left with NH, this NH, then this is a box, then NH, then H and OH being removed. So what you have bond between carbon and nitrogen. Then C double bonded with O, this box is there. C double bonded with O, H and OH being removed. So if I remove this H and OH, there will be a bond between carbon and nitrogen. And this bond, C double bonded with O and N, this link is called amide linkage or peptide linkage. Amide bond or amide linkage, or you can also say peptide linkage. So this is how a nylon is formed by mixing the diamine with dicarboxylic acid. A polymer is formed. And why we call this as a condensation polymer? A long chain compound is formed, but also it releases water. How it releases water? Because if this hydrogen is removed and this OH is removed, what this H and OH will result? H plus OH. What is the result? The compound it will form? So it will form H2O. So there will be water molecules as well. So because the polymer plus water is formed, that's why this kind of polymerization is known as condensation polymerization. The previous polymerization, only the small molecules were joining and forming a long chain compound. That is called addition polymer because only one kind of molecule was given off. Is it clear, the concept of condensation polymer? That when small molecules join together to form a long chain compound with the release of a water molecule, we call that as condensation polymer. You have to learn the monomers. You have to learn these monomers, name of these monomers, structure of the monomer, and you should be able to draw the polymer as well. Now, these are not the total molecules. It will have many molecules. Like these are, I only draw like here 4 molecules, but there will be n molecules, like too many molecules which join together, but it will have a same repetition of the structure. That's why we put n here. You can see I put a bracket and write n. So what does it mean? It means it continue till nth molecule, the last molecule. Finish writing, drawing the structure. Yeah, what about others? The second type of condensation polymer, which you have to learn and practice the structure, is polyester. And these are man-made or synthetic polymers. So formation of polyester, what are the monomers? So here the monomers in case of polyester are many molecules of diol. Diol means two alcohol groups at the end, and dicarboxylic acid. So diol, if I want to draw the structure of diol, so di means two and ol means alcohol, so two OH groups will be there. But between them, there's a carbon chain, so we cannot just draw a line. If I draw a line, it means oxygen bonded with another oxygen directly. But there's a carbon chain. Instead of drawing that carbon chain, what we can use a symbolic representation, we can use a box. So this is diol. And then dicarboxylic acid, as we just drew, the dicarboxylic acid. So two carboxylic groups, and between them there's a carbon chain, so we represent with a box. Same way, another molecule of diol and a molecule of carboxylic, dicarboxylic. So these are the monomers. How a polymer is formed. So to form a condensation polymer, basically H and OH should be removed. So what happened? It's up to you. If one molecule loses its H, like example, if one side it loses its H, the other side it will lose its OH. Same thing, one side H, another side OH. One side H, other side OH. One side H, other side OH. Now when we draw the final structure of a molecule, so we remove, if I remove OH from the first side, first one, if first one I remove OH, the second one should be H. But if first one is H, second one should be OH. So this will be O, then a box, and this H and OH being removed. What I circle is removed. Then this will be O, because this OH and H being removed. So this will be O, C double bonded with O, the C double bonded with O. Then there is a carbon chain. So this is a carbon chain. Then C double bonded with O. This OH and H being removed. So OH and H being removed. So I'm left with O. And then this box. Then OH and H being removed. So this will be O. Then C double bonded with O. So this box was there. Then OH and H being removed. So O will be there. C double bonded with O. Then this box. And then C double bonded with O. And put bracket and N. It means it will continue like this. So this is how a polymer is formed, condensation polymer. And what is this bond called? C double bonded with O and O. What is the name of this link or a bond? C double bonded with O and O. What we call this link? C double bonded with O. C double bonded with O you will find in ester. This is called ester linkage. In the previous, C double bonded with O and N. So this C double bonded with O and N is called amide linkage. But it is C double bonded with O and O, that's called ester linkage. And this polymer is known as polyester. You have heard this name like the polyester. So polyester is actually a polymer which is synthetic polymer, man-made polymer by combination of dicarboxylic acid and diol. Many uses are there polyester. And what else will be there? Yes.
So this is only ester linkage only.
Only ester linkage. C double bonded with O and O. And the previous one was having amide linkage. Why amide or peptide? C double bonded with O and N is called amide or peptide. C double bonded with O and O is called ester linkage. Plus, because H and OH are being removed, so what it will give? It will give water molecule. So H2O will be there.
Sir, in the last example, why didn't we consider hydrogen?
Which one? You mean this part?
Yeah, yes.
No, actually, if we, the main structure, it's C, this linkage is there. Because you have C double bonded with O. So if C double bonded with O is connected to nitrogen, we call amide. If C double bonded with O is connected to oxygen, what else is there other than this? Anything can be connected to nitrogen, but we don't bother about it. But what is connected? Nitrogen can form 3 bonds, so it will be like this. So what else? Maybe hydrogen is there, maybe any other substance is there, but the linkage is not changed. So C double bonded with O and O is ester, and C double bonded with O and N is called amide or peptide linkage. So even hydrogen is there, hydrogen is not there, it will not make difference to the linkage. It's called the same amide linkage. That's why even I did not highlight this hydrogen, because even hydrogen is there or not there, that will not make difference to the linkage. Is it clear, the structure of polyester? Draw this structure of polyester. The reaction conditions you don't have to learn. So manufacturing the nylon example, if you want to manufacture a synthetic polymer we want to make. Nylon is also called polyamide because poly means many and amide refers to amine groups are there. So example, you have dicarboxylic acid and you have diamine. Two are the liquids. So what will happen as we mix them together? So it will give fumes here. The solutions are immiscible. Immiscible here refers to the two liquids does not mix with each other. And interaction, like the place where they interact, the molecules react with each other. What this result? This will result in a formation of a nylon. So this is a nylon, a formation of a nylon. And as they continuously react with each other, you can see continuously the place where the position where the molecules are colliding, forming a nylon. So you can just roll over a glass rod. So even with this solution, you can have several meter nylon. And you can see the strands are getting thinner. Why it's getting thinner? It shows that the number of the molecules or the reactants are decreasing. Is it clear, the concept formation of nylon? This was formation of a nylon. So the monomers are dicarboxylic acid and diamines. And this is a synthetic polymer. Why we call this as a synthetic polymer? Because synthetic polymer or man-made polymer, you can say. So nylon is also called polyamide. Why we call that as a polyamide? because it contains amide linkage. Many amide linkages are there. That's why we call polyamide. So condensation polymerization can be artificial. There are many artificial condensation polymers, but you have to learn about nylon and polyester. And the other one is natural condensation polymer. We'll discuss next week, because the next session I will discuss the test paper with you and the weekly homework. You have to learn the uses of nylon and polyester. Two uses of nylon and two uses of polyester. You can use your book to write the two uses of each polymer.